We start on this guideline for electrical wiring in residential building, document by Energy Commission Malaysia, Suruhanjaya Tenaga Malaysia. Is a regulatory body to administer electrical related activities and also gas also electrical related activities and also gas as a owner of our electrical supply X, electrical supply X. Okay, this document is quite long. I mean, quite old, 2008. But I think the standard, as mentioned, is just same. We don't change much on the standard wise. Only maybe the method of installation might be more. The content, the table of content of this document. We're going to read what this document is about 55 pages, very short one, but the narrative of the document need to be go through one by one. So there's a content of introduction, purpose, references, and from here we will see the documentation that been used to develop this guideline. So as I mentioned that our work as an electrical engineer maybe will be much depend not only electrical engineer, all engineers actually depend on a lot of compliance, compliance on the standards, compliance on the X, compliance, uh, maybe guidelines on handbook, code of practices, and whatnot. So based on that, the reference also is very, very important and will be discussed in this document. We have also to introduce our supply system, even though we have talked about it last week on the electrical supply specification, because we need to specify our supply character not to suit of our equipment. So this supply system is also important to suit of our equipment needs. Talking about the voltage level, talking about that what we call it, frequency and those things. Then we'll talk about electrical wiring, compliance to the legal requirement. Why is it very, very important? We need to plan our wiring work, features of electrical wiring. What are the features that we have in electrical wiring? Example of lighting circuit schematic drawing, socket outlet schematic drawing, and also final circuit for 13 amp socket outlets. And then we're going to talk about control and protection system electrical wiring, selection of control protection, isolation, protection, and cable, selection of cable, factors related to cable carrying capacity, the cable type, use of minimum cross section. We will talk about cross section area, protection conductor minimum cross later on, function, flexible cable function. So this is about cable and the accessories, electrical accessories, selection of wiring accessories. And last week we talked about earthing and electrical installation. But we don't touch before the previous document. We have limited time, so we are going to talk about the earthing lightning protection today. This one lightning protection here? Oh, there is no lightning protection over here, but it's okay. Let's see if we can go back to the document to talk about lightning protection first, then we can come back to this document because there is no lightning protection. Earthing only. Inspection. This is very, very important to explain about what kind of inspection that do we have in our system. And some of it will go over body safety and forms, the related forms. So the lacking part of here is actually the lightning protection, but we know why, because this is a residential buildings. So for residential buildings, lightning protection is minimum. It's minimum. So let's have a look into the lightning protection first for the last lecture. Then we come back to this lecture. Want to continue to talk about this guideline? So this is different. This is different. Because we have ended at chapter or part 10 of the document. So we want to talk about this one, cable trenches, we have talked about it, and now we're going to talk about this lightning protection. Okay, lightning protection system for structure as an additional from our past lecture. Because this is also important, because in this document we don't have lightning protection because it's just residential. Lightning protection is non-residential, is more appropriate to discuss. All right. Okay, as an introductory, let us So deselect this, because this is quite also important. Okay, in our lightning protection, we got three main parts. The first part will be the air terminal. Secondly, will be the down conductor. The third one will be the earth termination system. So these three main parts in lightning protection. I'll try to draw later. But initially, uh, okay, let's try to find some way. Just okay. This one is okay. Just enough for us to understand. Okay, lightning protection comprises of these three main parts. The first one, let me cut these things because we can we can draw something for okay. Lightning rod. Salah je ni. Sepatutnya lighting. Lightning. Lightning. So this is the first part, lightning rod, which are these air termination. Air termination or lightning rod. This one, the first part. The second part, as mentioned in the document, is down conductor. Down conductor indicated this one. Okay, this is the down conductor. This document. Earth termination system indicated actually here, where in drawing they will show like this. This is from down conductor. This is the lightning rod. One, second, and also third. So this is second. This one is the third one. Okay. So these three main parts. We're talking about lightning protection. We've got three main components or three main parts. Very, very important to understand this first thing. But in order to connect this between down pipe, down conductor and earth terminal, the earth terminal, okay. This is down conductor, so kita pakai pen lah. Lightning. This one is down conductor. This one is earth terminal. So lightning rod or air terminal can also be used. Air terminal. Okay. So these three components lah. Air terminal, down conductor, earth terminal. Earth terminal. So these three main part as mentioned in this document. So one more also mentioned, but we seldomly take it as our component, which is this one, separation distance equipotential bonding. We don't talk it as a component. It's actually the method. It's not a component. It's a method of bonding or separation distance. So this is a method. Okay, so they got a figure over here, but it doesn't matter. We will go it later. No problem. Okay, now isolated from structure to be protected. Location and facilities not isolated from structure to be protected. So make sure that we spell it correctly, because it's lightning, not lighting. So the document tadi, this one, salah eja. lighting rod. It's not lighting, it's a lightning, but it's okay lah. It's a non, it's a Google just to find the image only lah. But the spelling is wrong. Okay, location of facilities, and the third one, what do they say? Okay, the purpose of lightning protection to reduce physical damage due to lightning flashes to a structure. But I will say that actually not four, just three only. Don't add one more. We'll get it very confused. Very confused to the practitioner to add one more separation distance and whatnot, because there is not a component. It's actually the method of installation. Okay, now next structure with non-metallic roof. Non-metallic roof. What to talk about this? Non-metallic, and there's also a metallic roof. Okay, they got a difference between non-metallic and also metallic. What does this mean? So non-metallic, what is metallic roof first? A metallic roof meaning to say that it's just as simple as metal roof lah, metal deck. Huh? So there is different of method of installation. Non-metallic, for example, what is non-metallic roof? Um, Flat roof, concrete. Concrete flat roof. We have also our genting tu, uh, tile, etc. Including concrete tile, concrete roof tiles. uh. So metallic is a metal decking roof. So what is the how to find this metal decking roof? Metal, simple. We have a lot in our um PPCAS, PPCAS lah, FKTA. This is metal decking roof lah. We have a lot in our big FKTA office. Metal deck and non-metallic roof. Other than that lah, this is metal roof. This is non-metal. This is also this what we call that, clay finishes. This is also clay finish. This is also clay finish. This one is metal. This is also metal. This is also all metal. So we got two different approach to run or to install or to lay our roof, our lightning protection, depend on the type of roofing. So meaning to say that this roofing, this roofing consider as a concrete, apa nak panggil ni? Concrete flat roof. So while having this concrete flat roof, the installation is different. If we have a metallic roof, the installation is different. So that is the meaning by this statement lah. I don't want to read everything, but there is the statement of non-metal and also metal roof. Okay. Okay, this is how it goes, but we're going to go for the drawing. It's more clear for us to refer. For structure taller than 60 meters, a lateral air termination system shall be installed at top 20 of the lateral air termination shall be installed at the top 20% of the height of the structure for protection against lightning strike at the side of the building. So what does it mean? So a structure taller than 60 meters, this kind of building, for example, and it is more than 60 meters. So 20% of it need to be covered by lateral. And we got one more terminal. A terminal. This is also lateral. Huh? This is what I mean by this statement. Huh? If there is no metal facade, it might be bonded or form part of the air termination. Part of the air termination. So this is air terminal. So part of it will be need to be bonded together. So they need just like you need an enclose of the patented. So let's see. I've seen one of the recent building using that method. TRX is using that method. Is it TRX? Yeah, this one. New building in KL just completed last year. Huh? You're from KL, you will see this what we call it building, huh? Somewhere in Sungai Besi there. Not this one. So this is under construction. For the top one, they'll change the facade into this look. Is there any more features that we can, here it's more clear. This is a new building in KL. Beside one more new building become another attractions of buildings skyscrapers in KL. Oh, okay, no, 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 that's here. This one, this building, and we got one more. This building, also in Kuala Lumpur, with very nice new buildings, and you can see this is not, of course, this is not the lightning protection, but part of it is actually a lightning protection purpose. This one, and this is actually meant for the telecommunication. This building in Kuala Lumpur also, in Kuala Lumpur. So we got two new coming, two new completed building in KL. This is one of it. Sorry, not this one. This one, Merdeka Tower. Merdeka Tower building. My consuming is not good. Let's try to find Google. Just through Google. Yeah, much better. Yeah. So we got this aerial or antenna of the building. This one. Now become the, I think, the highest building in the world or in Malaysia. I'm not I'm not sure. But due to this, the telecommunication antenna over here is very, very uh, iconic. And we got one more, TRX, also just completed last year. This one, as mentioned just now, just completed last year in Kuala Lumpur, close to this one, close to Sungai Besi there, to Raza. And the Merdeka Tower is actually close to our Merdeka Stadium, last Merdeka Stadium. So this is part of things that have been constructed, and we can see the concept is there. LPS conductor. What is LPS? Lightning protection system shall be installed on metal deck roof. Okay, now talking about metallic roof. So for non-metal roof, we will go through the drawing or to the picture later. And also for this one is metallic roof. So how to install? On metal deck roof is a metallic roof. It does not form a part of air termination system. Shall be installed on metal deck roof. If the metal roof does not form the air termination system, nanti we'll see later. Down conductor. Okay, now we talk about air termination. This is talking about down conductor. A down conductor should be installed at each exposed corner of the structure. This is the I can say spec lah. but it's not necessarily lah. It's not necessary because we need depend to the design. We need to depend on the design. Down conductors should be installed straight and vertical such that they provide the shortest and most direct path to Earth. Okay, how to understand the down conductor? Let's see some pictures. Down conductor. Down. Okay, this is all the down conductors. This one still coming. Down conductor. Oh, this is Faraday cage. It's more complicated design to protect the building. So sometimes we don't notice about this. Most of the time lah. If you're not an electrical engineer, we rarely notice about this installation, but they are in our buildings. Such like this one. This is a down conductor. This is the air terminal. See, this is a metal wall, but they still install the down conductor there. It to me it's not supposed to be this way lah. But it's okay. Should be no problem since they got it on the design. And where else? See this one also, the down conductor. We they're using this um copper tape to lay the down conductor. What else? To lay the down conductor. So okay, okay, that is actually mentioned by the drawing here. So the down conductor. So the air termination or down conductor. So that will be the second part. The down conductor should be not installed in the gutters or down spouts, even they are covered with installation. It does not be installed. Don't install down conductor in the gutters or down spouts. What is down spout? Rainwater down pipe. Rainwater down pipe. Don't install. Even if it's covered by insulating material. Method, how to install? We got 2 or 3 methods now. 3 methods. I mentioned about 3 methods. The first method, expose. Expose it, fix to the wall. You can pin it and test point later. Test point will talk later. So, for example, this one, expose. Expose down conductor. Expose. And we can see also in last picture. Uh, expose. See. Okay, the installation. See, expose down conductor. And we can also put it into paint if you want to paint it, or you can also cast in concrete, meaning to say that you put in a wall to avoid vandalism, because these things, sorry, this thing is quite expensive. This thing is quite, it's a copper tape. Copper material, I think about 6 to 9 ringgit per kilogram. So it's very expensive. It's so exposed to the vandalism. So basically, the best is to encase in concrete so that we can avoid that vandalism. We embed in the reinforced column or structure, or you can also put inside the brick. But normally, how do they encase? If you got two-story building, for example, this is the air terminal, This is a down conductor. We can put it exposed. At one point, they will go into the wall and keluar balik. So this part will be exposed. This part will be encased. So this also being practiced. Because why? It's very difficult to reach to the top if you want to vandalize or steal the copper tape. It's very difficult. So that is why uh, this might be exposed, but this one they will encase in the concrete. So that at the lower level they don't worry about the vandalism or attempt to steal the thing. Okay, properly clamp to the structure rebar 1 meter intervals. This one is structured bonding or Faraday cage. Structured bonding. Let's see if we have this. LPS, the RUC to URL bonding. Okay, we don't have this. They don't have this. Let's see lightning connection. Is there anything to be shown over here? No. Structured bonding. So typically, structured bonding is we use our rebar as one of the carrying materials, lightning carrying materials. But I cannot see any of the drawing or any of the pictures can show that. I have old pictures, but I need to here, yeah. We can do something like this. No, yes, something like this. Let's see. Okay, good. This one is good enough. Even though the spec is not there, but it's okay. Just to show you how it been done. First of all, you can see this red pen. This is the earthing. You can see it's different from the bar. This is the rebar. This one is actually the lightning protection. Lightning cable lah. Boleh lah. So this one is the rebar. So they bond it into this clamp. That clamp will be erect together with the bar. So you can see the bar over here, and they clamp it together with this lightning cable. So you can see this is how they do. This is another clamp. This is clamp. This is the what we call that, the lightning cable. This is a rebar for structure. This is another rebar, and that is how they've been installed. So we name it as a structured bonding. LPS, Lightning Protection System. So there is a few more pictures to. I think we can use this. Okay, let me open up one more file so that we can have it for you as a note. Here, because I put it into drawing. Why not? We just use this as our reference note letter. Okay, now clear. And one more example. This is strain gauge difference. This is Riba, where can we can find it? No, I think that's only the picture that we have. This is the same pictures just now. We cannot see other than that. Oh, this one too. Yeah, this also. No, no, no. This is pending. Is there any more picture for that lightning protection? This is normal rebar. We cannot see any other work method on doing this. So basically, that is how we erect lightning protection for the decage. That's for another structure. But there's a paper writing about this. There's paper. Even myself also have a paper to talk about this land. Use of use of use of rebar for lightning protection. Yeah, things like this. So they use rebar at the same time clamp it with our electrical what we call that conductor for lightning protection. So for this one, yes, this is another picture that we can use as our reference. Can see things like similar but not. This one is the sorry. This one is the electrical lightning protection. This one is actually the of course the bar bar, and it clamp over here. Clamp. So there is another one. Put it here as your reference. And can we have more? Just to show you more. No, I cannot see. For this one, no. Uh, so, but it's very common and popular in Malaysia, just to avoid case of vandalism. Okay, so there is increase in concrete. Use embed to the reinforced concrete column or structure. Properly clamp structure rebar at 1 meter. At 1 meter intervals. This is also the standard for them lah. And connected to air termination via test point install. This is test point. Test point later. I will touch it later. Test point I will touch it later. Now, the third one, we can use also the natural components. So we got three methods of installing this lightning protection. The first one, we put it exposed. Secondly, encased in concrete. The third is use of natural components. What are the natural components? Whatever conductive materials can be used. Always remain. Structure will not be modified. Make sure the structure is not modified. Metal framework is very useful for this. May be used as part of LPS. So for example, for metal building like this, if all of these are metal, if all of these are metallic materials, including the roof, so basically we don't have to use any lightning protection system in here. If all these are metallic materials, we don't have to put our lightning protection over here. No need. No need. Because the building itself is actually metallic or structured metal. So we don't have to put anymore. And same goes to this type of building. If everything's metallic material, so we just use as it is. Only the condition remain. The structure will not be modified. Don't modify lah. For example, interconnected reinforced steel must be there. The reinforced steel must be there. The steel column, the steel beam, the steel ground, everything must be there. So it's actually a complete metal things. So if we got a complete metal things, we don't have to use our other than these two above. Meaning to say that method of down conductor for exposed also not required. For this one also not required while using your. It's not a natural component. Basically using of building component. The word building component is more accurate. It's more accurate rather than natural component. Natural component sometimes they use, uh, maybe wood materials is not suitable for lightning protection. Okay, okay. Now, steelwork within reinforced concrete structure is considered biologically continuous provided that the major part of the question are vertical and horizontal are welded, blah blah blah. So this is the condition to use our building material as condition to use building material as basically building envelope as LPS system. LP lah, LPS lah. Line operation system. Okay, this is the condition. So in order for us to use the building material as sorry, apa je ni? So this is the condition to use building material of valuable as lightning protection system. So one more condition is must be vertical bar must be welded, clamped, or otherwise securely connected. So how to put a secure connected? It must be using this welded or clamp materials, or it's continuous. Don't have any joints if possible, but must be joined over there lah. Okay, so down connector, we have talked about the air terminal. We could talk about the down conductor, and now we go for the last part, which is the earth termination system. So the earth termination system, the third part, the third part of earth termination. Where was our better we use this. No, no, no. This is not. This is not. This is not the best one. I think this one is the best one. Yeah. I'm going to use this one. Okay. So for example, this one is the air terminal. This one is the down conductor. Now we want to talk about earth terminal. Earth terminal. So the earth terminal, okay, put it top. The earth terminal, here. Earth termination system. Down connector should be connected to the earth termination system consists of earthing connector and earth electrode. So in earth termination system, we got these two main things. They are earthing conductor and also earth electrode. So let's see from the internet. Okay, this is not right. Earthing, 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 earthing. Earth chamber. This is more accurate. Earth chamber. You always see this, I think, in in our construction. So this is the earth pit or earth chamber. So the thing will be here inside. So this is how it been prepared and cleared. So inside you can see image like this. If you open it up, basically it's a connection between down conductor and also earth terminal. Okay. Then actually earth chamber connection. So this is the earth chamber, and this is how it been here. This is the bare one. Okay, this is the bare one. So on the top of it, let's see. The top of it will be the surface that we can see. From here, actually, we can see from here, but we cannot see what is actually underneath the chamber. This is basically the rod, earthing rod, and they will be installed vertically in the ground, and will be connected by using this dowel. We can connect by dowel to connect everything. So it's actually a copper bonded together, copper bonded together to give our uh, earth connection between that. Okay, now, so this is the earth pit. Earth pit conductor. This is how it been installed. So on the surface ground, we will just see things like on the surface ground or the ground surface, we can just see things like this. This one, showed by the arrow here, or things like this. Will be mentioned about the earth pit, for example. So this is how it been covered. How it been covered. So this concrete cover will put it, and it will be enclose everything on the surface ground. So we cannot see much inside there. So basically, this is how it been installed. This is how it been installed. So the earth copper here, this is actually the concrete earth pit. So this is the detailing part of how they're gonna install this thing. Okay, let's move it into our materials. Okay, continue. Two type of earth termination. This one I don't want to touch. Make you confused only. Don't have to. We just talk about there is down conductor to be installed. The earth termination system consists of earthing conductor and earth electrode. Done. That is the thing. So the drawing will show you something like this. So this is the surface. This is the down conductor. This is earth terminal. Okay, so done. Next, this is the fourth part, separation distance or equipotential. This is to me mainly for electrical engineers lah. So basically, you don't have to know much about this lah. So let the engineers of electrical engineers to do this part. One more thing is related to this bimetal connectors, eco-potentialization, electrolytic corrosion. So this thing is we pass to them lah. Let them decide lah. You don't have to worry about this thing. Okay, now go for the the what we call it, cross sectional of lightning protection system. I think I've shown more clearer pictures on this. Actually, they just crop this from AutoCAD drawing there, so they show the image is quite blurry, but it doesn't matter. We have shown you in other document just now, so it's blurry, so we don't have to read. And this one is more clear for us to make understand. But you can see the drawing also not related to our kind of installation. We really, I mean, this kind of sawtooth roof. This is actually the name sawtooth roof. Sawtooth roof is very uncommon in Malaysia. Uncommon. But I think that is not the important part. The important part is to show you this. That is the important part. So the sawtooth roof is not uncommon in Malaysia. I think this is image from Google too, and this is the I mean the lightning protection system when we talk about residential. See, we have this air terminal, down conductor, and also the earth chamber. So these three parts talking about lightning protection system. So when being asked what is the component of lightning protection system, always remember just three things. Lightning protection system component, we have one, air termination. Secondly is the down conductor. And the third part is actually the earth chamber, earth terminal or earth chamber. So this is three main components of lightning protection system. Okay, now non-isolated external. This just want to show the how they install non-isolated external lightning protection. So this is the lightning protection installed at the house. Okay. One more thing that we need to understand or just to know lah, not to master, is actually how do they calculate the numbers of terminal that is required. So they're using protective angle method. So this is the protective angle. This is the angle. So let me try if I can see. I can 10 years ago lah. I'm not sure if I still have the document or not. What is this? No, very less now. 10 more than 10 years ago. So the idea is to use the calculation to calculate how many terminal do we need in order to protect our installation. So basically, they just using the protective angle method. Protective angle method means to say that one terminal can protect how pitch is the protection angle. So this is area where we'll get the protection by calculation lah, by calculation. So we need to find, for example, this one and this one. This is the protective angle. So this is protected angle. So protect by this also become one more component to be protected. So things like that. But it's an electrical related calculation design. Okay. Okay, here. This is things related to the installation of copper tape on non-metallic surface or non-metallic roof. Okay, non-metallic roof. Ini macam roof tiles. Roof tiles. Okay, things like this. Okay, this is also for concrete roof. concrete roof. Okay, so this is basically the components: air terminal, nut, air terminal base, copper tape, DC tape, square tape clamp to clamp this thing together. So you have this as a material to be installed, or the material. Okay, this is how been installed. It's actually very simple. The design also quite simple, but need to go through by this kind of distance and requirement. Okay, on roof, how it been installed. Separation distance and also those installed on the wall or installed on the parapet and so forth. Okay, higher than 60, as I draw just now. So this part must be metallic, and installed on the side, so that we can have a lateral. If the lightning occurs, uh, it can be proposed to strike in this area lah. Of course, one thing about lightning, we cannot ask lightning to strike wherever that we want. We can just prepare the best design in order to assist us when the lightning occur. Okay, this one, another method of having the design is by using a rolling sphere method. You can use a protective angle. You can use a mesh method, or you can use hybrid. That is why for high building, hybrid installation is also been used. So meaning to say that they don't rely on just one method. They use all three methods to design. This is more to the design. Rolling sphere, protective angle, and also mesh method. Okay, now if our structure is metallic material, such as lead, steel galvanized, or titanium, or copper, or aluminum, or zinc. I mean the roof, metal roof. The thickness is mentioned here. The thickness of the material is mentioned here. To use that building materials or roofing materials as our lightning air terminal. So this is the lightning LPS. This is a metal roofing. So you can see from here that this installation using the building materials, in this case roof, as the air terminal, using roof, metal roof as air terminal. So this is how it been installed. Yeah. So the title is very simple: bonding to metallic roofing. So whatever kind of metallic roofing can be used as our bonding material roofing. Settle. So to install on the lightning protection on the metal roofing, this is the method lah. But there must be a thickness requirement for the for the for the metal roof, because we want to prevent puncture, hotspot, or ignition problems. So the minimum thickness is also mentioned in this booklet lah. Number one and number two. Okay, done. All right, next one. This one is how to install. I've shown the pictures more clearer. This is the lightning protection material. Okay, this is actually the surface roof. Huh? All right. Okay. Some pictures. Huh? So this is how it been bonded. A row with standing stem, a standing seam, and this is how it be. This is more clear pictures to show you how it been actually installed on the roof, on our roof. Huh? Okay. But things like this, if we have this what we call it, metal roof, if we have this metal roof, this one is actually not required. Huh? If we can go for this kind of installation. See, they just clamp on the metal roofing. So basically, this is optional only. Yeah? It become optional. Optional to have LPS. Better to go for bonding. Better to go for bonding. So this is the meaning by this picture, but it's good to show you lah. It's good to show you lah. If I can decide, I better decide this method. Installation, you just clamp on the metal decking by comply of this requirement, complying of this requirement, and you don't have to lay the copper tape along the roof, along the roof. If you're constructing, for example, warehouse 100-meter long, for example, and using the metal decking, of course, they will be very, very costly to install this lightning protection compared to this method. Compared to this method. So there is things that you need to clarify as electrical engineer lah. Okay, they also the drawing, but you cannot show quite detail. We have also a test point. I've also mentioned about test point just now. So let's try to talk about test point. Okay, test point is a location where the copper tape is what you call it? Is prepared in a box. Either you want to normally we use either bimetal or straight joint from copper to copper or aluminum to copper or GI to copper, things like that also happen because this material not necessarily copper. Sometimes they use different materials. Aluminum can be used, even steel rod can be used, even stainless steel can be used. So in order to them to get it eco bonding potential, so one thing that they need to go for this test point, and here the installation of bimetal need to be there. Bimetal means two metals join become one, or actually to change the property of one metal to another. So this is the function of this uh, test point, one thing. Secondly, for testing, of course, because the name is test point. The name is the test point. So basically, to test. To test what? To test few things. The continuity of the installation up to the top, or to test also the earth, what you call that, resistance letter. So there is a calculation to measure about this earth resistance. Okay, and see, you've got one more component over here, which is search counter. This is property to measure how many lightning beams strike to that area. So, but it's very barely used except for TMB substation. You got TMB substation, search counter will be installed just to calculate how much the occurrence of lightning at that area. Okay, next. Almost finished. Almost finished. So this is the pictures of lightning protection, we have this air terminal run through the reinforced here. This one clamp connectors for connecting LPS connector with the reinforcement. They clamp the LPS here, clamp it to the reinforcement bar. Oh, this is, you can see, good practice. That what we call as a structured bonding. Huh? This also same thing lah, same thing lah. But they're using different material. This one is copper tape. You can see copper tape over here. This one is earth wire. Where is the earth wire? Here. And this is actually the reinforced bar. So this can be used also. And they use the earth wire, clamp it with the approved materials to the rebar. So also good practice. Okay. There is also using a copper tape. This is copper tape, but installed without proper clamping. Non-approved connection between earthing tape and reinforcement, the way we may be able to stem, blah, 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 blah. So it's a bad practice. And also, they run the cable inside the column without any clamp, no clamp. This is also considered as a bad practices. So this is an example on how it can be installed in our construction work, in our construction building. So this is part of thing that we need to understand. As you none even you are not the electrical engineers, but you will find this in your workplace later. Okay, this one we can skip. This one also we can skip. This talking about the cornering. This one we can explain later. So this is the part from the down conductor. This is the air terminal. Another down conductor to the earth chamber. So this is actually the earth chamber. This is how being installed in our industrial practice. Okay. One more thing. The installation of lightning protection can be as start as during the piling steel bar work, span pile cap steel bar. So from here, they can actually install the lightning protection somewhere here. Clamp it into the span steel bar. Somewhere here, clamp it into the span steel bar. So this is the pile cap. Later on, become the pile cap or footing. And this is the reinforced bar from the span pile from here, from the span pile here. And the reinforced bar been joined with our RC bar. This is the bar. And from that bar, our lightning protection can be installed along the way, starting from the footing, huh? Starting from this bulkhead. And now, starting from there, it been erected up to the top level. So reach to the point where sampai sini lah. So from footing, raise up to the top floor. huh? To the top, actually, to the roof beam, to the roof beam. I will try to draw later. I will try to draw later. So this is sorry, this one, starting from the reinforced concrete footing, and will be climb to the column, to the top of the building, until we reach to the roof roof beam. Reach to the roof beam. Okay, this is how they install, and they put detail on the what we call that, the column, to climb up as a concrete bonding. So this is actually to create something for suit this design. Something to suit this design, they're using this drawing to show you lah. This drawing to show. This is detail P, detail Q, blah blah blah. So this is where the clamp is there. So they've calculated all this. So I'll try to draw. Later. So here, how do they do the clamping part? If you can see, really from here, this is G clamp. You can see also. Okay. Where is this is the clamp detail, and detail P is actually, this is detail Q. This is detail P, clamp detail P. This is detail P. This is not Q. This is supposed to be P. This is detail clamp here. So this is the clamp. We name it as a G clamp. G clamp. Okay, let me padam ni. Ini bukan. So the G clamp is just this one. Okay, this is the G clamp, where you clamp like this at your bar. So this is your rebar. This is the bar. And this is your copper tape. So you've got three materials over there, just to show you this is how it been installed. So that clamp, to clamp together within bar and also your lightning protection. This is for clamp. This is for earthing. Detail N for earthing. In this drawing, detail N is actually here. For here. Okay. Okay, we can skip this. Also, we can skip this. Done. Done. Correct. Okay. This is things about to talk about lightning protection. We've got about 1.5 hours too. It's not that simple. But I will try to go for example, you can have area for me to draw to you in the same document. Okay, we can use this one, I think. We can use this one because we have things being installed over here. Now what we're going to do is to layout, change to the orientation of landscape, and we move into the third page. I'll try to draw to you. Margin, we put this as narrow as possible. Size is A3, the big one. So for us to draw, raise it later. No problem. Okay, now as a summary, to discuss about this is basically, I will try to use my design and my drawing to show to you. This is basically the things that we have discussed about. The first part, or lightning protection system, will comprises of these three main things. They are LPS component. Air terminal, down conductor, and also earth terminal. Okay. So to understand, it's very simple. We have this air terminal, down conductor, and earth. Okay, these three important things, huh? Air terminal, down conductor, and earth terminal. This is the lightning protection system. Okay, these three main important things. But in order to you to understand more, starting from the beginning on how we install it, we can start with this design. Huh? Okay, now starting from your footing, pile, pile apa nama dia? Piling lah. Huh? Rubber. And then you have your pile cap. So from here you get few installation from your existing pile, and then from here we started to erect our footing, and it will be linked up to earth. Uh, not sorry, ground beam, pile cap, stump. Hmm? So we have the reinforced bar over here. 2. So now we can have our lightning protection can be started somewhere here and erect this way, erect this way, erect this way. We install together by clamp, by clamp. So as the building is installed, let's say you go for first floor beam, first floor beam, and the light version will be raised and installed along the way. This is your ground beam. You install this way and merge back to your another stump over here. Sorry. And it's actually installed also from here, this bottom. Install. Actually this one and this one is copy sajalah. So this building will raise as a column and meet to the first floor, and the installation is continuous. Raising on the LPS. CNS. Okay. Up to your roof beam. So yang ni you multiply by n je lah. How many floors we don't care. Up to your roof beam. So our light position will be ready over here. Ready. Ready for what? If you put for example, a pitch roof. Let's say this is a metal decking, pitch roof. Sorry. let's say this is a metal deck pitch roof. So our lightning protection will be here and just clamp it into the metal decking. Clamp. This is your, let's say this is a metal roof fit. Same about this area. Clamp. Clamp. So basically, all of your roof it, here will become equally potential. You need to say that this is actually your air terminal already. You don't have to put another air terminal over here. You don't have to put another air terminal over here. Not required and not need anymore. Eh? And your structure will become the carrier of your lightning protection system. This is your structure. This is your ground beam. This is your intermediate beam. This is your roof beam. So your structure will become the carrier of the lightning protection wire. So this is where lightning protection we use this cover. That's where installation here, and then you run through the beam over here, and you climb up, install, run here, climb up, install. So it's become the complete set of your lightning protection system. As long as you are using the metal decking roof for that purpose. So just climb over there. So this is how it illustrates you how actually a lightning protection is installed. How actually lightning protection is installed. Okay, one more thing that's also important I missed to put here is actually your earth chamber. So this is your complete set of let's get this is your lightning wire, this is your lightning wire, this is your lightning, we name it as a bare conductor. Lightning, sorry, bare conductor. It's copper. This is your earning. And here is actually your test point. So in this case, we don't need air terminal because your roof become air terminal. Roof become air terminal. So this is our concept of Faraday cage in LPS. So this is how it can be illustrated for you to understand about lightning protection system, as mentioned in the document that we have discussed and read just now, about 1.5 hours just to explain about this lightning protection system. I think with that note, we should end here. I don't want to go for another document. This is quite heavy for you already. Quite heavy for you already. Only now, the thing is to understand that lightning protection is part of very important area in our installation, and also will be very very useful for you to understand on how as a non-electrical engineer to work with our electrical engineers members in order to deliver the lightning protection things for uh our students lah, for our sorry for construction method lah. So 9:32, I think I want to stop there because this is quite heavy for you. Let the thing settle first to understand about this. I will try to get back the recording session later so that from there maybe you can have a look, and see what is actually happening in our construction of lightning protection, so some of it I've put here, the detail of what we can find from Google Images, and also my last drawing is to show you how it's being installed in our industry. So before I stop, is there any question that we need to discuss, or you want to ask anything? Please, we can do that.